My dear students, let me welcome you all to a new general revision of physics. In this edition, you will be encountered with multiple choice questions. And once again, they'll be of gradual difficulty. And I'll give you time to think. So let's get started. In Compton effect, the ratio between the velocity of the incident just before it collides with the free electron and its velocity just after collision. Okay, velocity after collision, it is equal to 1, okay? And I said it before. And the ratio between the wavelength of the electronic beam used in the electron microscope and the mean wavelength of the light used in the optical microscope, is it greater, equal, or less than 1? Of course, it is less than 1. The following graph represents the relationship between the wavelength, lambda, of some photons and reciprocal of their momenta, lambda versus 1 over PL. What about the slope? Of course, it is de Broglie equation. The slope of the opposite graph is speed of light, Planck's constant, energy of the photon, or mass of the photon. Of course, it is Planck's constant. The force produced by a beam of photons of power PW on a surface when reflected, okay, on it is obtained from the relation 2PW over C. Yes, force equals PW over 2C, and C over 2PW, and 2C over PW. Of course, it is, yes, well known, it is 2P, yes, over C. Another choice, the momentum of a moving photon is obtained from, yes, A, H over lambda, H lambda over C, H over lambda C. As I said, we can, yes, obtain the answer from de Broglie equation. Lambda equals H over PL, so momentum equals, yes, the first choice, H over lambda. The wavelength of the wave associated with a moving electron is obtained from where H is, yes, Planck's constant, is the linear HPL, H over PL, PL over lambda, and MV over H. It is de Broglie equation once again, so momentum of the electron having a mass m, okay, is the mass of the electron, velocity is v. What about the choice? The right choice, once again, it is de Broglie H over PL. Which of the following statements about a moving electron is incorrect? Electron has dual nature. Okay, electron has only a particulate nature. Electron is negatively charged particle. The wavelength of the wave associated with the moving electron decreases when the velocity increases. We want one of them is, yes, is not correct, is incorrect. Of course, it has dual nature, so the wrong one is electron has only a particulate nature. Okay. Another choice. The figure represents an experiment done on electronic beam. The experiment proves something. We've got a source of electrons, okay, and it is directed into a plate, and we've got a pattern of interference. So what about what does this experiment include? Includes something very important. Okay, once again, the figure represents an experiment done on an electronic beam. The experiment proves that, yes, we will see. What about the choices? Electron is negatively charged. The electron is negatively charged, but this has nothing to do with the experiment. Electron has a constant mass, also has nothing to do with the experiment. When we've got a interference pattern, this proves that the electron has, yes, wave-like property. Electron has wave-like properties as well as a particulate nature. This is the right answer, of course. In the following circuit, V equals VR. V total, V source equals VR. And this indicates that we are in resonance state. Impedance of the circuit equals R. Yes, quite true. I, VR is replaced by I, leads VL by 90. What is your opinion? The phase angle between VL and VC is 180. It is quite clear, and it is always so. V1 equals 0. So phase angle between voltage and current is 0. Okay, so all are correct, all are wrong. 2 only is correct. 1, 3, 4, and 5 are correct. Some other responses. It is quite clear that 1, 3, 4, and 5 are correct. We've got, yes, some figures here. And which graph best represents the relationship between inductive reactance of a coil and frequency of the current? We've got a direct, yes, relation. So is it A, B, C, D, or E? Okay, it is. We want a direct relation, so it is number D. And what about the graph which represents the relation between ohmic resistance and frequency? Well, it is independent on the frequency. So which one? A, B, C, D, or E? Of course, it is C. And what about the graph that represents the relation between impedance of the circuit and frequency? Yes, great, it is. Is it A, B, C, D, or E? Yes, it is B. Relation between impedance and frequency, and the reciprocal of it will be the relation between current and frequency. Okay, relation between capacitive reactance and frequency, XC equals 1 over 2 pi FC, so it is an inverse relation, so it is the first one, number A. Another choice, in hydrogen line spectrum, Lyman's series is produced when electrons fall from an outer shell to the shell, N, where N equals 4, M, N equals 3, yes, N equals 4, and N equals, yes, 1. Lyman's, yes, it must be N equals 1. Another choice, in Palmer's series of hydrogen, the spectral line which had the longest wavelength among the following transition is produced when electron decays from N7 to N2. In Palmer's, with the, yes, electrons should, yes, decay to N2. Okay, first choice, from N equals 7 to N equals 2, N equals 3 to N equals 2, N equals 7 to N equals 1, N equals 2 to N equals 1. The last one is wrong, of course. We want the longest wavelength, so we want the smallest gap, the smallest energy. It must be, yes, from N3 to N1. Which one of the following statements about pores is incorrect? electrons move around nucleus in discrete energy level, and this is correct. When electrons decay from an outer shell to an inner one, amount of energy is released, and of course, this is correct. Atom is electrically neutral, correct. Coulomb's law and Newton's laws cannot be applied. Actually, they can be applied. This is the incorrect one. Which of the following statements about X-rays is incorrect? They are unaffected by magnetic and electric. Yes, because they are photons. They cause photoelectric effect, of course. They can cause Compton effect, of course. They have no effect on photographic. They have an effect. So this is the wrong one. The wavelength of an electron wave in a given orbit can be given from the relation 2 pi r over 5, 4 pi r over 5, 5 pi r, 4 pi r over 3. Okay, we need, to be, yes, we need a formula which is equal to 2 pi r over n, where n is an integer, okay? Which one? Of course it is 2 pi r over 5. And what about 4 pi r over 5? Actually, it is equal to 2 pi r over 5 over n. N here is equal to, or n equals 5 over 2. So it must be an integer, so it is wrong. And what about 5 pi r? It is equal to 2 pi r over, yes, 5 over 2. 5 over 2 is also not integer. So the right one is 2 pi r over 5. Okay. The value of the current, I1 in the opposite circuit. Your attention, please. Yes, there's something very important. Internal resistance here is equal to 0. And we've got just 2 resistors connected in parallel. We don't have any more resistors. So the voltage of the battery will be the terminal voltage. So voltage across 3 ohm resistor is 6 volt, and across 2 ohm resistor is 6 volt. And we want to calculate I1. So it's all easy. Yes, thank you very much. It will be, is it 2 ampere, 3 amperes, 6 amperes, or 0? Of course, 6 over 3, it is 2 amperes. Another choice. Now we've got a circuit. What about this circuit? It contains, yes, parallel combination that consists of 3 resistors, 8, 8, and 4, connected in series to 1.5 ohm resistor, and internal resistance 0.5. Okay, what about the question? Of course, we want the value of I2. Okay, the value of I2, the current passing through 8 ohm resistor. Is it 0.25, 0.5 ampere, or 1.5 ampere, or no correct answer? It is 0.25 ampere. First of all, we need to calculate total resistance and current through the battery. We'll do it one by one, okay? So total resistance equals 8, and 8 and 8 connected in parallel will give a resistance of 2, okay? Plus 1.5 plus 0.5, so it is 4 ohm resistor. Now it's all easy to obtain the current passing through the battery using Ohm's law of closed circuit. Current passing through the battery equals V battery over R total. So it is equal to 4 over 4, 1 ampere. And to calculate the current, in a combination connected in parallel, we need to calculate the voltage across this particular combination, okay? The voltage equals current times the resistance of this combination only. So potential difference across the parallel combination equals 1 times R equivalent of the parallel combination, okay? So it is equal to 1 times 2, it is 2 volt. Now it's all easy to obtain the current. The current equals voltage divided by resistance, voltage 2, resistance, yes, is 8. So it is 2 over 8. It is 1 over 4. 1 over 4, of course, it is 0.25. Another choice, we've got a circuit here, a parallel combination. One arm consists of 4 ohm resistor and 2 ohm resistor connected in series, all of them connected in parallel to 3 ohm resistor. The parallel combination is connected to 1.3 ohm and internal resistance 0.2 ohm. Total voltage of the battery 10.5. We want the current passing through the 2 ohm resistor. Your attention, please. Okay, is it 1, 2, 3, or 4 ampere? Okay, once again, it is 1 ampere, but we need to do it one by one. First of all, and the current also through the 3 ohm resistor, it is 1, 2, or 3, or 4 ampere. Yes, it is 2 amperes. How? We'll do it, as I said. First of all, we need to calculate the resistance. Resistance of 4 and 2, it is equal to, yes, 6 ohm. Resistance of 6 and 3 connected in parallel, it is 2 ohm, product over the sum. And total resistance of the circuit equals 2 plus 1.3 plus 0.2, it is 3.5 ohm. Now, it's all easy to calculate the current passing through the circuit. Current passing through the battery equals, yes, 10.5 over 3.5. It is 3 amperes. Okay. And now we need to calculate the potential difference across the parallel combination. So potential difference across the parallel combination, it is 3 times 2. It is 6 volt. 6 volt divided by 6. Okay, this is very important. The current passing through the 2 ohm and 4 ohm, yeah, are making just one resistance of 6 ohm. So it is 6 over 6, 1 ampere. And 6 over 3, it is 2 amperes. Okay, to calculate the current passing through the 3 ohm, 6 over 3, as I said, it is 2 amperes. Okay. A dynamo coil takes time t to rotate from 0 position, vertical position, till half the maximum EMF is induced. The periodic time of its rotation, this is very important, your attention please. I said some of the questions require deep thought and intense concentration. This is one of them. Okay, a dynamo coil takes a time t to rotate from 0 to half maximum. The periodic time equals 4t, 8t, or 12, or 16, 12t. So how? This is important. You'd better jot it down, write it down. I'll explain it. Okay, now the angle of rotation from vertical position, time, and value of the instantaneous EMF. Your attention, please. Just stay with me, okay? When the angle is 30, okay, say the time t1, the value is half the maximum EMF. And we've just, yes, solved one. We've just answered a choice depending on this. Okay, so to reach half the maximum EMF induced, the angle should be 30. Angle of rotation of the coil of the dynamo from the vertical is 30. Okay, to reach maximum, the angle should be 90. Okay, to reach the effective value, the angle should be 45. These are very important pieces of information. Let it be T3. EMF is then maximum. And what about the time, periodic time? Periodic time, time to complete one revolution, making an angle 360. And now, okay, at this particular moment, instantaneous is equal to 0 since it is starting from the vertical. And now we can compare, yes, 360 to 30. What about when dividing 360 by 30, it will give 12. Okay, and I advise you to write this slide, this shot. This is very important piece of information, okay? So comparing periodic time with T1 time have the maximum, okay, it is 12. Comparing periodic time with time the maximum, it is 4, yes, 4 times as great as, okay? Periodic time to the effective, it is 8 times as great as the time of the effective. These are important things. You should know it and you should write it down. Laser light is highly monochromatic because it has approximately one wavelength. Its photons have the same phase. It is parallel rays. Monochromatic means, yes, means they have just one wavelength. If the maximum value of an AC current generated by the dynamo, coil of the dynamo, is I, the average value of the current induced through a half revolution from 0 position is, okay, through half. So we need a relation that relates average and maximum. What about the relation? The right answer, first of all, is 2I over pi, okay? And what about the relation? I maximum equals I average times pi over 2. Average equals I maximum 2 over pi. I maximum given I, so the right answer 2I over pi. When the maximum induced EMF is obtained from an AC dynamo, the plane of the coil is perpendicular to, parallel to, at an angle 45 with the magnetic field. Here we've got something very important. You should bear something into your mind. We've got the vertical position where the magnetic field is perpendicular to the plane and EMF is equal to 0. The horizontal position where the magnetic field is parallel to the plane of the coil and EMF is maximum. And when the angle between plane and magnetic field is 45, we've got the effective value. So the right answer will be maximum, it is parallel. Okay, so the right answer is parallel to. In the following circuit, what will be the readings on the voltmeter and the meter? Okay, we've got here something very important. VL equals 300, VC equals 300, and this means that the circuit is in resonance state. Okay, what happens in resonance state? Actually, we've got something very important. In resonance state, VL equals VC, XL equals XC, V total equals VR, voltage and current are in phase. V total equals VR, and the impedance is a minimum and is equal to the ohmic resistor, okay? When we bear these things into our mind, then we'll be able to answer the question. So the current, so the voltage across the resistor must be equal to the total voltage. Total voltage is equal to 220. And what about the impedance? It is equal to the resistance, 100. So 220 over 100, the current must be 2.2. Let's see the choices given. Okay, is it 800 volt and 2 amperes, 302 amperes, 220 and 2.2, 102? Of course, it is 220 volt. This is the voltage across the resistor. It is equal to the voltage of the supply because we've got a resonance state. Current is obtained by dividing 220 by Z. Z in this particular case equals R. R is equal to 100. 220 over 100, 2.2. So C is the right answer. One change that would be necessary to convert a rotating coil DC generator into a C generator. Usually we do the opposite. Okay, what about this change? Let me say it again. What it changed? One change that would be necessary to convert a rotating coil DC generator into AC. I'm converting DC into AC. So what a change needed here? Stronger permanent magnet, slip rings instead of a split ring commutator, a single brush instead of two brushes, an extra coil on the armature. Of course it is number B. Slip rings, yes, slip rings instead of a split ring commutator. A copper core, we would never use copper coils. Okay, extra coil, these are nonsense. Okay, so the right answer is slip rings instead of a split ring to convert, yes, to convert DC to AC. Which one of the following about a moving electron is incorrect? Okay, what about the electron? Electron has dual nature. It means it has particulate nature and wave-like nature. It behaves as a wave and it behaves as a particle, and it is negatively charged particles. Okay, so which one of the following statements is incorrect? Okay, electron has dual nature. Actually right. Electron has only a particulate nature. Wrong. Electron is negatively charged. Correct. The wavelength of the wave associated with the moving electron decreases when the velocity increases. And also this is right. So the wrong one is electron has a particulate nature. Okay. Another choice, the purpose of, and this is very important, of the commutator in a simple DC motor is, what is the purpose function of the commutator? Is it, first choice, reverse the direction of the current in the coil twice in each revolution, reverse direction of rotation of the armature twice, reverse polarity of the magnet to stop the armature getting overheated? Of course, it is the first choice, to reverse direction of the current in the coil twice in each revolution.